Um, so here we're just continuing with the page 81 problem. So as I was saying at the very end of the last video, to find the first quartile, you would take the total number 200, add 1, 201, divide by 4 to find the first quartile. So that would be 201 divided by 4. That's about 25. I'm sorry, that's about 50. Um, and so it would be the 50th or the 51st person. So you would draw the line about there, go over to the yellow line, start going down, and then it would give you about 58 for the weight of the 25th percentile or the um, first quartile person. So then the last thing it says is to use this information to make a box and whiskers graph. They have to give you additional information for this because the cumulative frequency graph doesn't tell you exactly where each person is on this weight range. And when you draw a box and whiskers, at least the minimum and the maximum, they need to be exact numbers. So the minimum number is normally not, 0, and the maximum number is normally not the last number here. It's usually within the range. So like between 75 and 80, the maximum person is somewhere between 75 and 80, but where exactly is that? Where they're going to tell you it's 76. And the minimum person is somewhere between 45 and 50. You don't know exactly where. They're going to tell you it's 47. So the box and whiskers plot for this distribution, the 47 and 76, are very easy because they give them to you right here, lowest weight, highest weight. You just need to make sure that you mark it exactly on the number line at the right place. Now the middle three values, which are here around the box, that is the first quartile and the median and the third quartile. The third quartile, if you remember, we got 68. The first quartile, if you remember, we got 58. So we put 58 and 68 as the first and third quartile. Now the median value we know is 63 from the graph also. So we got the middle three numbers from looking at the graph, drawing these lines, horizontal line and then a vertical line, and where it crosses the x-axis, that's going to be your weight for the first quartile, median, and the third quartile. And the minimum maximum, remember, you get from the word problem. So that is part E, and we're now done with the page 81 problem, and we'll move on to the page 126 problem, which is a line equation problem. First of all, it gives you the equation for a line. It says it's y equals negative 2x plus 6. Now, if you remember, when you get a equation in the form y equals something x plus something, these somethings here, the m and the c, have special meaning. And the m's special meaning is gradient or slope, and the c's special meaning is the y-intercept. So once they give you an equation already in this form, you can immediately graph it. So let's graph it because that'll help us answer some of these questions. Now we know that it's going to go through the y-axis at 6, so we mark this point here. And then we know that the gradient is negative 2, so that means the rise is negative 2 and the run is 1. So negative 2, the rise would be going down 2, and the run would be going over 1. So that would be go over 1, go down 2, go over 1, go down 2, and that would be the graph of that line. Now the point A4 lies on L1. Find the value of A. Okay, so like x equals something and y equals 4. Where is that? Well, we can already see that when y equals 4, it would be this point right here. So A, they say they don't know what A is yet. Well, A would just be 1, right? Because we can see from the graph that when x equals 1, y equals 4. Okay? And then the third, the B has the point 12.5 comma B lies on L1. Find the value of B. Now this is kind of harder. It looks harder, but it's not really. So x equals 12.5 would be way over here, and we can see that the line would go down here, and maybe that value would be a huge negative number. We don't know exactly what it is, and we say, oh my gosh, how are we going to figure out this from the graph? Well, you're not. You're going to just use the equation. Y equals negative 2x plus 6. It's already in a perfect form for you to put x equals 12.5 into the x, and then you just use algebra to solve negative 2 times 12.5 is negative 25 plus 6. Okay, negative 25 plus 6 is negative 19. So what do you know? We already have the y value, negative 19, for the x value of 12.5. And then we look at the last part. They give us the equation for another line, 3x minus y plus 1 equals 0. This time they did not give us in y equals mx plus c form, so we cannot immediately graph it by looking at this, but by doing algebra and moving it around, we can. So let's take this equation, and then we'll graph it by putting it in gradient intercept form. So we take 3x minus y plus 1 equals 0, and then we want the y by itself on the other side, so we add y to both sides, and this side here becomes 3x plus 1, and this side here just becomes y. So we can see that this equation here is actually y equals 3x plus 1. Once we know it's y equals 3x plus 1, well, the gradient is 3 and the y-intercept is 1. The y-intercept is 1, gradient is 3, which means you go over 1, up 3, 1 over 1, up 3. We draw a green line. It crosses the original L1 line at the point 1, 4. So we already know that from the graph that the intersection is 1, 4. So I'll put that here. They asked for the point of intersection. I'm going to show you how to do it in two other ways because, depending on the problem, one of the ways is easier. So we just use the graph to figure that out, and we just use the graph on paper because this was a pretty easy example. Now let's try to use the poly SMLT tools on the calculator. And the way we're going to do that is first we need to put these two equations in the form that poly SMLT expects it, which is an x term and a y term, and then on the right side it wants the constant term. X term, y term, and on the other side they want a constant term. So one of our equations is almost in that form, which is here, 3x minus y plus 1. It's almost in the standard form which poly SMLT wants. The only thing we need to do is move the 1 over to the right side. The way we do that is we subtract 1 from both sides, and then we get 3x minus 1, this is gone, equals negative 1. So that's the top one. And then the bottom one, it's pretty close also. We just need to move the x over to here. If we move the x over to here, then we'd have x, y on the left side, and we'd have 6 on the other side. To move x over here, all we need to do is add 2x to both sides, just algebra. So if we add 2x to this side, we get nothing here for the x, and we're just left with 6. We add 2x to this side too, and we get 2x plus y. So our equation would be 2x plus y equals 6. Okay? And then we're just going to use poly SMLT, which you get by pressing apps, and then you go to poly SMLT and you press enter, and then you press any key, and then you go down to simultaneous equation solver. And we're going to use the coefficients here. The coefficients are the numbers that are multiplied times the variables. So we're going to use the 3 coefficient here, and this coefficient, hey, there's nothing there. This confuses a lot of people. There is something there. It's called negative 1. You just can't really see it because whenever we multiply 1 times something, we usually just don't write the 1. But actually this is negative 1y, right? This is plus 1y. So the coefficient is negative 1. It's not positive 1 because there's a negative there, right? So, and then this one, the coefficient is plus 1. So we have 2, 1, 6. We have 3, negative 1, negative 1. So we write it in this form, and now we're already ready to put it in here. Do you see how it's in the same form here? So we're going to write 3, and then we'll go down, 2. You can just press enter also. Enter also works. Go up, we'll put negative 1, down, and then we'll put 1, down, and then we'll go over and we'll do the constant terms on the right. So negative 1, down, and then we put, negative 1 on the top. Negative 1, down, and then the bottom one's going to be 6. Okay, so I think we input it right. Now we're just going to press solve, and it's going to give me the solutions, which are x1 equals 4 and x2 equals 4. X1 equals 1 and x2 equals 4. Now what does x1 and x2 mean? We didn't have x1 and x2. We had x and y. Well, basically when you put your coefficients in this order. I put 3 first and I put -1 next. That means that the first variable is going to be the one that's connected to the 3, which is the x, and the second variable is going to be connected to the -1, which is the y. So basically, I'm telling the calculator that the first variable is x and the second variable is y. And the calculator comes back and says, well, your first variable solution is 1, your second variable solution is 4. Now I need to go back and say, well, my first variable is x, so x equals 1 and y equals 4. What do you know? That's the same solution we get from the graph that we made. And now I'm just going to show you one final way to do it, which is to do this graphing solution in the calculator. The way you do that is you use this form of the equation, which we use the same form here. So we're going to take the gradient intercept form and we're going to put it in the calculator. Now, the gradient intercept form is not good to put in for poly-SMLT, because if you remember, poly-SMLT wants you to have in the x, y, and constant form, and this form is like y's on the left and everything else is on the right. Now the calculator is good at using that form if you press y equals, oops, we got to get out of poly-SMLT. I'm going to press 6 and I'm out. Okay, then I'm going to press y equals and I'm going to put these two equations in there, and they're already ready to put in. -2x, remember to use this button for x, plus 6. Then I go down and I put the other one, 3x plus 1, 3x plus 1. Now it's already ready. I'm going to graph it. Now doesn't it kind of look like the graph I made here on the paper? Now I know from looking on the paper that this point here is 1, 4. I can't really tell from looking at this. So there's a way to find that though. You do second calc, and then we're going to look for the intersection. So we go down to 5. That's 5. And so the first curve is at, no, I'm not sure if I was, let me do that one more time because I don't see what the calculator led me to there. Okay, intersect, enter. Okay, so it says y equals -2x plus 6. Is that the first curve you want to look at? And I say, yes. And then it says y equals 3x plus 1. Is that the second curve you want to look at? And I say yes. There's only 2 curves in it, so obviously. And then it says, do you want to make a guess of x equals 0, y equals 1? That's fine. And then it tells me the intersection of the two. So it says that the intersection is x equals 1, y equals 4. Hey, what do you know? That's the same answer. So that's 3 different ways you can use poly-SMLT to find the intersection, because poly-SMLT essentially is taking 2 lines and figuring out where they cross. Now when we do word problems, sometimes that's hard to see because we never draw a graph, but every time you do one of those word problems with 2 variables and 2 equations, what you're doing is, in the graphing world, is you're drawing 2 lines and you're seeing where they cross. Because that is the only way to satisfy both of the conditions that are given in the word problem. Now I'm going to stop this video, and the next video we are going to talk about the page 192 problem.